Hi, welcome to
A P Physics Try 3 Enrichment.
Alright, hi Mr. Howard.
We're here at a park.
We're here at Liberty Ridge. There's some kids playing on the playground over here. We definitely didn't draw on this wall. Alright, but we're here to
This is already here.
This is already here when we got here. Yeah, someone already worked the math out that we already worked out earlier today. In not during finals, that's for sure. We calculated how fast Ant-Man had to travel in the quantum realm for 5 years to equal 5 hours. So, a little knowledge on the quantum realm. The quantum realm is a microverse, tiny teeny verse within the Marvel Cinematic Universe's multiverse. The only way to travel to the quantum realm is through magic, the little sling ring that Doctor Strange has, and pin particles invented by Hank Pym, which Ant-Man uses to be the big small. Alright, so the quantum realm, according to the Marvel Cinematic Universe fandom page, in the quantum realm, space and time are irrelevant. But that's been disproven by the events of Avengers Endgame, where Ant-Man goes down to the quantum realm and comes right back up, but he traveled through time. And that's also been essentially. Here's our math. Sam, you want to explain the math?
I'll explain the math. This gets a little crazy. Okay, so we had to convert 5 years and 5 hours both into seconds. 5 hours, 18,000 seconds. 5 years, a lot more seconds. I think that's 157 million, roughly. So then we're going to use the standard time dilation, where it's time proper over gamma is equal to the time relative. So we have about 157,784,760 over the square root of 1 minus v squared over c squared is equal to 18,000. So we're going to multiply 18,000 by gamma and then divide by 18,000. So we get 8,765, and we divide the time proper by the time relative is equal to gamma. We square both sides, and then we're going to get 76.83960 million, which is a lot. And we're going to get that is going to be equal to negative v squared over c squared. We're going to multiply both sides by the speed of light squared and get a really big number. 6.915 times 10 to the 24th is going to be equal to negative v squared. We're going to distribute the negative, and then we can't take the negative square root because he's traveling faster than the speed of light, which is impossible because none of this is possible.
Yeah, time dilation equation doesn't like it when you travel faster than the speed of light.
It really doesn't like it. It's impossible because it doesn't work, because the only way that it works is if this is less than 1, because otherwise you're dividing by a negative number, or you're taking the square root of a negative number, which you can't do, and the only way that is, or more than 1, is if you're going faster than the speed of light, which he is, which is not okay. We don't allow that. He broke the laws of physics, and that's illegal. Theoretically, if you just take out the negative sign and just set it aside and forget about it, like it doesn't even exist, then you figure out that he's going about 2.62474 times 10 to the 12th meters per second, which is a lot faster than the speed of light.
Heck yeah, it is.
That's heckin' fast. He's gonna get a speeding ticket.
Yep, speeding ticket in the quantum realm. So Mr. Howard, back for round 2. Joe did this one, most of it, so I'll let him talk.
So in this clip of Tom where he actually flies out, he's able to magically stay in the air for 13 seconds, but then we look at it again, he somehow managed to stop horizontally. So we calculated the time that it takes for from the dock to when he stopped was 5 seconds, and then we estimated that he was traveling at 18 meters per second. And so using that we can we can calculate the acceleration at which he's slowing down, which is negative 3.6 meters per second squared. And then we searched the average of weight for a cat, which is 15 pounds. It's pretty much 6.8 kilograms. And so using that, we're able to find the force horizontally that is exerted on Tom that is making him stop. And so we multiply the mass by the acceleration, and we get negative 24.68 newtons. So out of nowhere, probably a P, he was able to exert 24 newtons of force on Tom to make him stop, which is pretty insane. And then we looked at it vertically, and then we saw that Tom never changed horizontally for 13 seconds, meaning that he was up here for 30 seconds straight. And then Using the mass that we found out earlier, which is 6.8 kilograms, we calculated that the force of gravity on him was 66.64. And so that means the magical V was able to push Tom up in the opposite direction of the force of gravity for 13 seconds at 66.64 newtons. What a strong V.
Yeah.